guys, today we're going to be talking about solving equations containing one radical. So again, this is going back to Algebra 1 when we're solving equations. However, now we're introducing radicals into the equation, right? So the same rules will apply, all right? We're just going to use our knowledge of radicals to go about solving these, all right? So again, when you solve an equation, the goal is to isolate the variable, and that's what we're going to do here, all right? So don't be confused by the radical. All right, so using our properties of radicals, we're going to go ahead and solve this. So the first thing we want to do is we want to try to isolate the radical. All right, so notice I have a 2 here, so this is multiplication. I want to divide both sides by 2. So I'm going to divide by 2 here and divide by 2. Right, this will cancel, and I'll be left with the square root of x plus 1. And we know that 14 divided by 2 is going to be 7, right? So at this point, we need to figure out how we can get rid of that radical. Now remember what a radical is, right? We can write it as an exponent as well, right? So we can write this as x plus 1 to the 1/2 equal to 7, right? That's the same thing mathematically, okay? And knowing that, look how we can get rid of this. If we square both sides, right? If I square this side, right, what's going to happen? It's going to be 2 divided by 2, which is 1. Right, and this will be to the first power, right? Essentially, I'll get rid of it, right? And same thing on this side. So I'm going to square both sides, right? So if I square this side, we determine that the exponent will become 1, and we'll just be left with x plus 1, right? Equal to, but what we do to one side, we have to do to another. So 7 squared is going to be 49. All right? And our last step here is just to simply subtract 1 on both sides, so our answer here is going to be x equals 48. Okay, and that there is going to be our final answer. Alright, so that is example 1. Let's try another example. Okay, so we can have 5 times the cubed root of, and we'll do 4x plus 3 equal to 15. So again, when you're solving these equations that are dealing with radicals, you want to try to isolate the radical, okay, by itself. So notice this 5 here, right? We're multiplying 5. We want to divide both sides by 5. So divide both sides by 5, then we're left with the cubed root of 4x plus 3 equal to, well, 15 divided by 5 is 3, right? And again, look how we can rewrite this. Now, how can we rewrite this as an exponent? So it's a cubed root, so it's like with the square root, we wrote it to the half, right? Now that it's a cubed root, it's going to be to the third. So we can write it like this. 4x plus 3, all to the third, right? Equal to 3. Now, how do you think we're going to get rid of this exponent? Well, we're going to raise both sides to 3, right? Because 3 divided by 3 will be 1, and we'll be left with an exponent of 1. So essentially, we'll just be left with this part here, right? So we're going to go ahead and just raise both sides to the power of 3. So we'll have 4x plus 3 equal to, now 3 to the third power is going to be 27. Okay, so almost done here. Let's subtract 3 on both sides. So we'll be left with 4x equal to, so 27 minus 3 here, so we are going to get 24. Divide by 4 on each side, and x here is going to equal 6. Alright, so our answer here is x equals 6. Alright, okay, let's try another example. Okay, next one, we can have 4 plus, we'll do the square root, x minus 1 equal to, and we'll do 5. Okay, same thing, isolate the radical, so we want to subtract 4 on both sides. Subtract 4 on both sides, right? Then we're left with the square root of x minus 1 equal to 1. Again, how do we get rid of this radical? Well, we're dealing with a square root, so we're going to square both sides, right? When we square this side, we're just left with x minus 1, and 1 squared is simply just 1, right? Add 1 on both sides, and our answer here is x equals 2. Okay? Alright, let's try one more example, and that will be it. So we'll have the following: cubed root of, and we'll do 3x 3x minus 4, 3x minus 4 equal to 2. Again, we're dealing with a cubed root here, and notice how it's already isolated. So in order to get rid of this cubed root, we're going to raise each side to the third power, right? So when we raise this side to the third power, we'll be left with just what's inside the radical, which is 3x minus 4, right? And 2 to the third power is going to be 8, all right? Well, let's add 4 now on both sides. Okay, we're left with 3x equals 8 plus 4 is going to be 12, right? Simply divide by 3 now. So we get x equals 4. So that is going to be our final answer there. Okay, and that's how you go about solving equations containing one radical.